Hello guys, you're welcome to my channel Fun with Physics. How are you guys doing? I hope you're fine, I hope you're good, I hope you're enjoying your day. In today's lesson we are going to consider the relationship between pressure and temperature of a gas and volume and temperature of a gas. As a starter, if you look at the picture there, you see a balloon inside a refrigerator, okay, and below it is exactly what happens when you remove the balloon after some time. Now the question that I have for you that you need to ponder is this, what happens if you put a balloon in a fridge? What do you think will happen when you put a balloon in a fridge? I want you guys to think about the question, and in the course of the lesson, you'll be able to answer the question yourself. Okay? Now, recall that pressure in a gas is caused by collision of a gas on the walls of the vessels, of the vessel or container, like you have in the picture there. You see the particles, air particles moving here and there and colliding with the walls, right? Now the collision is actually what causes the pressure. I've told you in the previous lesson. Okay? Now increasing gas pressure. When gases are not moving, which really occur, it means they won't collide with the walls and the pressure will be zero, isn't it? You know, I told you earlier that pressure is actually caused by collision. So when you're not colliding, the pressure is going to be zero. Pressure in tire changes with temperature. Okay, tire is like a closed system that cannot expand any further. Okay, the only way pressure will change there is if the temperature of the tire is hot. You know, the temperature of the tire, of course, is going to lead to the temperature of the gas inside the tire. So if you're driving on a hot day, the pressure inside the tire will be bigger than on a cold day. Can you explain your answer? Or can you explain why it is so? Why the pressure on a hot day will be bigger than on a cold day? Now if you look below the Formula 1 here, you see a lot of gases moving, colliding. These are separate different gases on a test. It's a test experiment actually. Okay, colliding with each other. So on a hot day, what do you think? What do you expect to happen? What do you think will happen to the rate of collision with this tire, the surface of the tire? Okay, now this will help us to be able to link the relationship between pressure and temperature. If you look at the screen, we have a container with a piston at a certain volume, at a fixed volume, or what you call constant volume, and the temperature of the gas is 9 degrees. Now, do you observe the rate at which the particles are moving and colliding with the walls? Now I'm going to increase the temperature to, like, let's say 40 degrees. What do you observe? Can you see that the collision rate, the rate at which they are hitting the walls, is frequent, it's more frequent? What can you say about the pressure now and the pressure then when it was 9 degrees? What can you say about the pressure? Of course, the pressure here is low because the collision is it's not as much as when the temperature is 40 degrees, isn't it? So we expect the pressure here to be low and the pressure here to be high, isn't it? At constant volume. Notice that the volume is maintained. I didn't adjust the volume, right? Okay, now we can come up with something with the relationship. With all of this that we've gone through, we can come up with a good idea. Now this is the idea by the top left hand side of your screen. Here where we have a low temperature, we see that the particles are moving slowly and colliding with the walls sluggishly, and that's not too frequent, so we have low pressure. And here at the other side here we have the right hand side, we have the particles moving very fast, they have high kinetic energy, they're colliding with the walls frequently, so they have high pressure. So we can conclude that pressure of a gas increases with temperature as the volume is maintained, that is at constant volume. Okay, now this is actually a statement that we can come up with from the few observations we've made, isn't it? So pressure of a gas increases with temperature at a maintained or constant volume. This can actually be carried out, can actually investigate, carry out this to check out. The car you saw earlier, the Formula One, was actually investigated, and the pressure in the tire was checked to see if the temperature, if it increases with increase in temperature. And in this case, after plotting the graph, it was observed, or it is observed, that for every 20-degree rise in temperature, the pressure increases at the same amount. Okay? Now, we want to look at the relationship between volume now and temperature. But before we do that, I want you guys to recall what we said earlier in the earlier video, the video we did some time ago about pressure, relationship between pressure and volume. We say that it's inversely proportional, right? Say that it's inversely proportional. That is to say that when the volume is doubled, the pressure will be halved. Or when the pressure is doubled, and the pressure can only be doubled when the volume is halved, something like that. Okay? And I told you guys that when you plot a graph of this relationship, you carry it out in experiment in the lab, you're going to get a graph like this, a curve graph, isn't it? Okay, but we want to look at the relationship between volume and temperature. Isaac knows that the pressure is inversely proportional to its volume, but he wanted to find out what happens to the volume when you heat a gas that can expand. He observed that the more you heat the gas, the more it expands. That is, the volume increases at a maintained pressure. Now, from what you have here below, the right hand side of the screen and below here, Isaac observed that at 100 Kelvin, when the gas is just 5 liters, and 1 atmosphere, when you heat it, increase the temperature to 200 Kelvin, the volume of the gas rises to 10 liters at the same pressure. Okay? Alright, that is what he initially investigated. Okay? But he carried out a common investigation, which we can all do at home if you want, to really check his facts. Okay, so he decided to investigate this time with a balloon at different temperature. He blew it up to less than half full. He measures the circumference of the balloon by putting a piece of string around the widest part of the balloon. Okay, now he held it in a warm water of about 20 degrees. Now the first one was actually at a temperature of 10 degrees, put in a liquid or water at 10 degrees. Okay. Now the next one is that he held it at in a warm water of about 20 degrees and observed that the volume of the balloon actually increased. Okay, and then he decided to repeat the same thing in water of about 30 degrees, a hot water of about 30 degrees, and observed that the balloon increased further. Okay, so from his investigation, he was able to write down, to come up with this table. At hot water, that is at 30 degrees, it was 18 centimeter. At warm water, that is at 20 degrees, 17, and at cold water, it's about 10 degrees, 16 centimeter. Okay, so Isaac found out that the temperature rises. As the temperature rises, the volume of the balloon increases, right? So the volume of the balloon keep increasing until maybe, let's say, the pressure inside is more than the pressure outside, then it can burst, isn't it? All right, now, but this is the kind of experiment we are going to carry out in the lab. A clear and better one. And in this experiment, we will need to use a pressure gauge on the container, a heating, a thermometer, and a heater, okay, to investigate. But this investigation here was carried out, and these are the results that we actually gotten. And we are going to do the same very soon in the lab, okay. And after plotting the graph, this kind of graph was obtained, right? So if you extend the graph to about a point here, you get this value, minus 273, which is known as the absolute value. You're going to learn more about the absolute value in the next lesson. You're going to learn more about that, okay? So as a closure, I want you guys to go to Google Classroom, or maybe you have your copybook. You can upload, or you can answer question on page 161 of your textbook. That is complete physics for Cambridge Secondary 1. If you can't upload it on Google Classroom, write it on your copybook. Okay, are we good? All right, have a nice day.